Welcome to the session on engineering graphics. In today's session, we are going to see the projections of hexagonal pyramid. So the problem statement given here is a hexagonal pyramid 25 mm sides of base and 50 mm axis length rests on HP on one of its corners. Draw the projections of the pyramid when the axis of the pyramid is inclined to HP at 40 degrees and appears to be inclined to VP at 30 degrees. So we'll see what is a hexagonal pyramid. So this is the hexagonal pyramid or the pictorial representation of hexagonal pyramid. So this hexagonal pyramid is having a base side. Okay, so A, B, C, D, E, F is the base of this hexagonal pyramid, and each side is 25 mm, which is given in the problem statement, and the axis O1 is 50 mm. It is resting on HP with one of its corners. So we can assume that D1 is a resting corner, and we have to draw the projections of this hexagonal pyramid. So this hexagonal pyramid will be having AB, BC, CD, DE and EF and FA are the base edges, 6 base edges, and AO, BO, CO, DO, EO and FO are the slant edges. So 6 slant edges and 6 base edges, and this O1 is the auxiliary line, which is nothing but the axis of this hexagonal pyramid. To start the projections of this, we have to start with the XY line, marking PP and HP here, and we have to draw the hexagon which is resting on one of its corners. So this is the hexagon of side 25 mm, which is drawn with a corner or the resting corner shown on right side of the observer. So once we do this, we have to mark all the diagonals of this hexagon. So where these diagonals intersect, that would be the O1 point, and from there we can project the axis length, that is 50 mm. So once we project, we can project the remaining points of the hexagon, that is A, B, C, D, E, F like this, and we can mark all the points, and then we can connect all these points to O dash, so that we will be getting all the slant edges of the hexagonal pyramid like this. So we have got all the slant edges of the hexagonal pyramid. So once we do this, the next step is that we have to draw the projections of the pyramid, and the axis of the pyramid is inclined to HP at 40 degrees. So here we used to, for the prisms, we used to follow the inclination of the lateral edge, because lateral edge was parallel to axis. But here in the case of pyramids, these lateral edges are not parallel to the axis, but there is one plane which is perpendicular to the axis, that is the base. The base of the hexagonal pyramid or any pyramid will be perpendicular to the axis. So to take the inclination with respect to axis, we will be taking the inclination of the base with respect to horizontal line like this. So to reconstruct the second phase, with axis inclination with HP, base inclination will be 90 minus theta. So this base is having 90 minus theta inclination, where theta is the axis inclination, which is 40. So the base inclination will be 90 minus 40, that is 50. So 50 base inclination, we have to take it for the base, and then we have to reconstruct this front view of the first stage as the front view of the second stage, having axis inclination as 40. So when you make the base as 50 degrees, automatically you will be getting axis as 40 degrees. So but always prefer to have the base inclination in the projections of pyramids. So if you maintain the base inclination as 90 minus theta, where theta is the axis inclination, you will be getting the axis inclination as theta. So this is the principle which we have to use while making the inclination with respect to HP of the axis of the pyramid. We have to go with the base inclination of the pyramid. So once we reconstruct this figure over here, we have to project all these points like this. Okay, so we have projected this A dash, B dash till F dash, and dash as well as O1 dash like this, and we have named A dash to A, we are getting A, B dash to B, we are getting B, and so on. Now while connecting all these points, so again you have to follow the procedure that is called the visualization procedure. So this procedure is little bit different than that of the prism. So procedure first step is same as that of the prism. So connect all outer points with thick lines, since border edges or the outer edges are always visible. So you connect this A to B, B to C, C to O, O to E, E to F, and F to A. So because these points are forming outer borders, if you connect using the line having thickness 0.4, this you can connect A to B, A to B, B to C, C to O, O to E, E to F, and F to A. So like this. The second, what we say that apex or base nearer to the observer is visible. So here if the observer is here, this apex is nearer to the observer. So apex side is visible and the base is invisible. So already E, F, F, A, B, B, C are the edges which we have already marked. So the remaining edges like this E to D and D to C will be invisible. So like this we will be marking the invisible edges. And then further is that write the nearest points to the observer in sequence. Now when the observer is here, we have to write down the nearest point of the base with respect to observer. So when you have got the observer, so first nearest point is A. So A we have written. The second nearest points for the observer B and F. The third nearest point to the observer is C and E. The fourth nearest point for the observer is D. So all the nearest points we have written here in the sequence. And when we have got these nearest points written down like this, the edges passing through these points will be the slant edges. So the slant edge passing through A will be OA. Slant edges passing through B and F will be BO and FO, and the slant edge passing through C and E will be CO and EO, and remaining is DO. So now we have to start with the first farthest point. So if A is the nearest and the D is the last nearest, so the D will be the first farthest. So D will be the first farthest. So the edge passing through D is DO. So the edge or the slant edge passing through the first farthest point will be invisible. So DO you have to mark it as invisible. So D to O you have to mark it as invisible. Then once you go for the farthest, then you have to go to the first nearest. So first nearest is the A, and the edge passing through A is AO, so that is visible. So AO you have to mark it as visible. So AO you have to mark it as visible. So A to O you are marking it as visible. So it is overlapping the DO. So there is no point in marking DO as invisible because this AO is overlapping the DO. But as per procedure we have already marked it. So DO. Then the third is what? The second farthest will be invisible. So second farthest are CO and EO. So CO and EO will be invisible. CO and EO will be invisible according to third point, but they are already visible according to the first point. So they have to be visible because they are forming the outer borders. Then the second nearest BO and FO are visible. So BO and FO are not marked and they should be marked as visible. So BO and FO should be marked as visible. So this is FO and this is BO which are marked as visible. So this is the procedure which you have to follow. The same thing has been explained using this procedure. So we will be getting the second stage like this. So after doing this, what you get is the axis length. So here you had axis length as 50 and here you are getting the axis length as 38.3. So now if you go further, you have to go for the normal method because the appears to be inclined to VP is 30. So here you have what apparent length and you are having apparent inclination. So true length, apparent length and apparent inclination, you have to go for the normal method. Okay, so you have gone for the normal method. You have kept the axis O1 on 30-degree line and you have reconstructed this figure. So this is the reconstruction and the projection from all the points of the reconstructed top. So you have taken all the projections from all the points of this and then you are naming them. So naming will be having like this: A, B, C, D, E, F and O1. So once you have the naming, so again you have to go to the final stage. We have to follow the same procedure what we had followed earlier. So that is, connect all the outer points with thick line as we are forming the outer edges. Then see the base or apex nearer to the observer. So here the base is nearer to the observer, so the base is marked as visible. And then again we have to mark down all the points. So when the observer is here, so B is the first nearest point, C is the second nearest point, A is the third nearest point, D is the fourth nearest point, F is the fifth nearest point and E is the sixth nearest point. So the last nearest is first farthest. So the edge passing through EO is invisible, but EO is forming here. So EO is here, so EO is marked as invisible. The edge passing through first nearest, so BO. BO is the first edge passing through first nearest point, that is B. So BO is visible. So BO you are marking it as visible. Then the edge passing through the second farthest. Second farthest is F and the edge passing through the F is FO, that is invisible. So FO will be invisible. Then we have got the slant edge passing through the second nearest will be visible. So second nearest point is C and the slant edge passing through C is CO. So that CO has to be marked visible. So already CO is marked as visible because it is forming the outer border. Then the edge passing through the third farthest, that is D. So third farthest point is the D and the edge passing through this D is DO. So DO is invisible. So D to O is invisible, which is shown here. It is little bit mixing with the CO, that's why you are unable to see it, but DO is marked as invisible. Then the last remaining is AO. AO is visible. So AO already forming the outer border and that is marked as visible. So like this you will be getting the complete solution and you can show it in this way. So this is the final solution for hexagonal pyramid having 25 mm side, 25 mm short, having axis 50 mm, having the axis of the pyramid is inclined at 40 degrees to HP. So this 40 degree you can show it in the form of base inclination, that is 90 minus theta. So if the base inclination is 50, you will be getting axis inclination as 40. You have reconstructed. Then the normal method you have used here because it is appears to be inclined to VP. So though it is apparent length, we have gone for normal method because apparent length and apparent inclination is given and we have completed the final stage here. So this is the solution for the hexagonal pyramid. Thank you.